Mazda 3. Mazda makes a great car, but their key fob sucks. Before 2019 they used this key fob. Then in 2019 they switched over to this monstrosity. This new key is gigantic. It feels like having a second iPhone in your pocket. Who wants this? They've gone backwards in almost every design choice for this key. I thought they could and should have done better, so that's why I hacked this into this. So what's wrong with the key fob? First and foremost, it's too big. It's huge. If I compare the volumes of each key fob with the latest Mazda key at 100%, the old Mazda key is 2/3 of the size, but my new key is less than 1/5 of the size. But the Mazda key fob has other problems. It's hard to open, hard to get the key out, hard to replace the battery. And one other major mistake, protruding side buttons. If you Google for remote key fob, you'll see that virtually all key fobs are made with either flush or recessed buttons on the front. I think there's a good reason for this. It's ergonomic, and it prevents the buttons from being pressed by other devices in your pocket. The key fob sits flat in your pocket, so if anything else is in your pocket, like other keys or a phone, then it's super easy to accidentally lock, unlock, or even panic. This happens frequently for me. As I disassemble a key fob, you'll see it contains 12 parts, excluding the key and battery. Half of that is just the outer casing. It has a latch to hold the back plate on, but the rest of the parts are friction fit and need to be pried apart. The circuit board is really simple. It contains an antenna portion here and a digital portion here, which on this side is just the battery ground. On the bottom are an LED and the buttons. If you flip the board over, you can see the digital portion in more detail. It has an Atmel chip made for remote key fobs, a crystal, and an unpopulated chip that obviously was not needed for my car. The buttons on the side are for lock, unlock, and panic. There's a missing button for trunk unlock, which I don't have on my car. It's only a 2-layer circuit board, so it's quite easy to follow the traces. You can follow the trace from the lock button as it goes along and to the Atmel chip. The plan is to cut out as much of the board as I can, along the sides here and here, and the entire bottom portion here. While doing so, I'll move the lock and unlock buttons to the front around here and here, and the panic button and the LED on the back I'll ditch because I don't care for them. Let's get right into it. I first mark off where I plan to chop off the board. I'm careful here to be sure that I'm only cutting away unused parts of the board. Then I add some test leads so I can easily hook up a battery for testing. I'll remove them later in the project. And lo and behold, attaching the battery works. No surprises yet, as I haven't really done anything. Here I'm using an X-Acto knife to score and then snap off the parts of the board I don't want. I file off the edge of the board to make it smooth. The battery ground pad was on there pretty good, and I don't have any special soldering tips to get it off, so I had to cut it up and take off the pieces. Before going any further, I wanted to make sure that the battery wouldn't interfere with the antenna, as I'm moving it a good bit closer in my design. So I gave it a try, and it worked fine. I needed to add a conformal coating because I'm moving the buttons to the front of the board over top of some exposed copper. The conformal coating is an insulating layer that will protect my button from connecting to the copper where I don't want it to. Now it's time to add the first button. Both buttons will be primarily secured only at one pin, which will be attached to the ground plane. So I want a good strong pad there. I scrape away an area of the ground plane where I'm going to solder the button. Here I solder down one pin of the button. Then I attach the other side of the button to the Atmel chip with 30 gauge Teflon coated wire. Later on I changed this wire out because it was too stiff. It kept breaking off as I adjusted the wire to fit the case. So I replaced it with more flexible 32 gauge magnet wire. I added the second button similar to the first. Instead of attaching the wire directly to the Atmel chip, I attached it to a trace where the original button was connected. To make that easier, I peeled up the traces on both sides of the trace, here. Then I cut the edges of the board off to shrink it to its final size, here and here. To secure the buttons, I've added RTV silicone to the sides. On the other side of the board, I added 3 tabs for the ground side of the battery. I added 3 to help the battery sit flat. To fit the case I'm designing, I need to cut out some indents next to the antenna. I did the rough cut with a Dremel and later smoothed it out with a file. I modeled the case using Autodesk Fusion 360 and printed online using Shapeways. The printer Shapeways uses is the HP Multijet Fusion, which produces really nice nylon prints. It took me 4 attempts before I got the design right. The battery holder keeps the battery in place and connects the battery contacts to the circuit board. I used adhesive copper tape around the edges as the positive battery contact. I was worried at first that it would be difficult to solder to the copper tape, but it wasn't. I wanted to paint the button text and logo with a color that popped. My daughter suggested a fluorescent neon green, similar to one of her nail polish colors. For the button text, I used 3 coats of paint over debossed lettering. Then I sanded the paint down so the lettering showed through. I glued the logo in place with super glue. And now the final assembly. First the buttons go in the case bottom, then the circuit board with the battery holder, then the battery, and finally the back lid snaps into place. And now for the final test. Lock, unlock, and it works.